Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Addition of HCl to alkenes, Markovnikov addition, and substitution elimination reactions involving tertiary alcohols with HCl. The product contains two CCl bonds. 1. A tertiary chloride at the ring junction carbon bearing two methyl groups, gemdimethyl at bridgehead. 2. A tertiary chloride on the isopropyl side chain carbon, CH3 to Cl. Now analyze each option with two equivalents of HCl. Option A has two ioxomethylene, terminal alkene, is equal to CH2 groups, one at the ring junction, exocyclic to the bicyclic ring, and one as an isopropyl group on the side chain. First, HCl adds to the ioxomethylene at the ring junction via Markovnikov. H goes to is equal to CH2, terminal carbon. Cl goes to the more substituted tertiary carbon at the ring junction, giving the gemdimethyl Cl at the bridgehead. Second, HCl adds to the isopropyl group via Markovnikov. H goes to is equal to CH2, Cl goes to the tertiary carbon of the isopropyl chain, giving CH3 to Cl. Both additions give exactly the observed product. Option B has an ioxomethylene at the ring junction and a tertiary alcohol CH3 on the side chain. First, HCl adds to ioxomethylene. Markovnikov gives tertiary Cl at ring junction. Second, HCl reacts with tertiary alcohol via SN1. The tertiary OH is protonated and leaves as water. Then Cl attacks the tertiary carbocation, giving CH3 to Cl. Both reactions give exactly the observed product. Option C has a tertiary alcohol HOC, CH3, at the ring junction and an isopropyl is equal to CH2 group on the side chain. First, HCl reacts with the tertiary alcohol at the ring junction, SN1 protonation of O. Loss of water gives tertiary carbocation at ring junction. Cl attacks to give gemdimethyl Cl at bridgehead. Second, HCl adds to the isopropyl group. Markovnikov H2 is equal to CH2, Cl to tertiary carbon, giving CH3 to Cl. Both reactions give exactly the observed product. Since all three options, A, B, and C, can react with 2HCl to give the same product, the answer is D, all of these. Therefore, the correct answer is D. Therefore, the correct answer is option D.